Okay, this is Mike Azida, and I'm about to present my next talk on uh, generative AI changes the world, maybe. So we're going to share the slides and walk you through these slides, put it on play, and away we go. Generative AI changes the world, maybe. 28th of June, 2024. Abstract of the talk. Generative AI is starting a new industrial revolution that is global in scope. The global desire for that technology maybe has started Cold War 2.0. A new industrial revolution? Well, in one, we see one of the many pundits making prognostications that present the possibility that generative AI is precariously pushing us into a new industrial revolution. We're not even sure we know what an industrial revolution is, but it usually presages great change in the way things are done and gets everyone up in a tizzy about having to modify what they do at all. In Britannica, we have the following definition: industrial revolution in modern history, the process of change from an agrarian and handicraft economy to one dominated by industry and machine manufacturing. These technologies changes induced novel ways of working and living and fundamentally transform society. I was reading that quote. So we're not changing from an agrarian and handicraft economy, except perhaps with respect to computer science and all teaching. And I'm going to try and explain how generative AI changes the world, maybe. You can see this in the paper. This is the architecture of this paper. We're going to use ChatGPT as our exemplary large language model representing generative AI. We're going to ask ChatGPT to build a course for us to learn about the Industrial Revolution. But when I started to do this, I didn't really know how to do this. But I found a YouTube video entitled Learn Any Language Easily with These ChatGPT Prompts, and I copied the prompts out and changed the How to Learn Spanish course into an interactive course on the Industrial Revolution in like 3 minutes. So here's the prompt I created. Here's the prompt. I'm going to read it to you. I am a complete beginner in the history of the Industrial Revolution. I would like to learn about the Industrial Revolution. I can study for an hour each day. Could you please create a structured learning plan to help me learn about the Industrial Revolution? Could you please recommend resources such as music, movies, TV shows, YouTube channels, articles, etc., that I can read or listen to increase my understanding of the Industrial Revolution? When you recommend an article, book, paper, YouTube video to read or watch, can you provide the exact title and website link? Can you role play out a conversation between two people who are talking about the Industrial Revolution? We will start off the conversation and then wait for me to respond before you reply. Great, let's create a structured learning plan for the Industrial Revolution. Here's a focused approach based on the Pareto principle, suggesting that 80% of your learning will come from 20% of the materials, focusing on key aspects that had the biggest impacts. Now that's ChatGPT giving me that sentence. What happens after you hit return is that ChatGPT responds by providing you the structured learning plan for the Industrial Revolution course, and that's figures 2 through 4, and I'm going to walk you through those. This structured plan is for an 8-week course. It is a concise syllabus that points the student towards what they should learn from papers, books, YouTube videos, music, movies, and TV shows. It tells you the precise articles to read and the web links to find the articles and videos. So here is the first page of the syllabus, weeks 1 through 2, foundations of the Industrial Revolution. And I'm not going to go through this. I'm just going to say here's week 1 through 2, 3 through 4, 5 through 6. And you'll see the things that are highlighted in blue, which are the links to the YouTube videos or the article if it's available online, or to Amazon if you've got to buy the book and it wants you to buy the book. All right. So it's pretty interesting. Week 7 through 8, review and reflect, and additional multimedia and other resources are listed. And when you get to the end of the syllabus, because I built this out of a Spanish language class prompt, it goes, now let's role play a conversation between two people discussing the Industrial Revolution. Alex is ChatGPT. He says, it's fascinating to see how the Industrial Revolution transformed societies, isn't it? From hand production methods to machines and new chemical manufacturing processes, the changes were drastic. And Jamie is you, the responded. Absolutely. And the impact on people's daily lives must have been profound. How do you think the average person felt experiencing such rapid changes? And your turn to respond as Jamie or another character. And you can see I've circled the headphone icon in the lower right. What you then do is you click on that. And all of a sudden, Alex, the chat GPT, is going to be talking to you, and you are Jamie or whatever name you want. And Alex has this strong driving personality, and you are the erstwhile deer in the headlights student responded. But you can see that this has the potential to be fleshed out to truly be a course on the Industrial Revolution, a course between Alex, the chat GPT-4 bot, and you, the erstwhile student responded. We didn't need a classroom for this. We didn't need to go anywhere. All we needed was a computer on the internet to reach ChatGPT and Alex, ChatGPT-4, and the properly engineered prompt. So I know this is not a very complex course plan, but what I wanted to point out is that course development and teaching can be individualized using generative AI as long as the large language model has been trained with the right material. The statement that I would like to make is that it is my belief that most in-classroom teaching at the K through 12 college graduate school levels can be replaced with right engineered prompts handed to an LLM like ChatGPT. Now, we don't completely have all of the appropriate engineered prompts written now, but what you should notice is that I didn't have much education or prompt engineering to actually write the prompts. I just needed a skeleton sample, one that the YouTube gods sent me without actually having to look for it. And what this means is that in the near future, teachers standing at the front of the room presenting or reading from PowerPoint slides will become a distant memory, just like the chalkboards used last century. This is kind of what I was thinking about when I wrote the previous column for IEEE Computer entitled, Do We Need Universities Anymore? The answer, I believe, is that we can learn probably 90% of what we need to know via a combination of YouTube videos and ChatGPT engineered prompts within the next 5 to 10 years, and that university and school real estate will become surplus sometime after that. Some of the biggest issues will be how do we learn to well write prompts for large language models for use in education and other applications, and how do we get access to computational resources and the large language models required. So it's prompt engineering or computer science, or maybe it's something else. In a recent interview, Jensen Huang, the CEO of NVIDIA, stated that generative AI will be creating new products, new services, enhanced productivity on a whole slew of industries, $100 trillion worth of industries on top of NVIDIA hardware in the next 4 to 10 years. And to make this happen, this will require that we graduate or educate tens of thousands of engineers capable of being able to properly engineer prompts for large language models and engineer the software and user interfaces that surround those prompts such that normal users can operate what has been built. The question becomes, where does this education happen? Historically, the tech industry has relied upon the field of computer science for that education, but this technological change is happening quickly, and universities move very slowly to create new courses and degrees. In 2005, I arrived at USC, and the computer science department was teaching an undergraduate compiler design course, a course the ACM had removed from the recommended computer science core in 1979, 26 years earlier. And there was no one uh, thinking about getting rid of that course. It still goes on for all I know. What I learned at USC was that if I submitted a syllabus for approval of a new course, say applied machine learning for games, that it would take 18 plus months in an unfathomable approval process that would end up with the course being approved with no changes to the syllabus and no one actually sending me any correspondence indicating that my course had been approved. And I'm told that most computer science departments operate at such speeds and processes. The other thing you learn in computer science departments is that if you actually list prerequisite courses for your new course, you might find out that the chain of prerequisites that allow you to get to your new course has a longer time requirement than the entire length of the degree program you're designing the course for. This might look something like the following list of 4 courses, each taken over sequential semesters, something impossible to actually achieve in a 3-semester MS in computer science program. So your first course might be Foundations of Artificial Intelligence. Your next course might be Machine Learning. The next course might be Deep Learning and its applications. And after that, Prompt Engineering Development in that 4th semester, which doesn't exist in this 3-semester long master's program. So the question becomes, how do we produce the engineers that can rapidly engineer the appropriate prompts and wrapper code for those prompts? The answer is, of course, YouTube video instruction or via online teaching platform like Coursera or Udemy. Universities really aren't capable of keeping up with the needs of the tech industry. Another thing that universities don't have is access to large NVIDIA compute farms where significant machine learning computation can occur. When I created the Applied Machine Learning for Games course, my students schooled me in the lack of available compute cycles inside the department. One of my student projects teams had a student that worked at USC's supercomputer center, and he was able to get his team's work running those machines. And that student suggested I call his boss at that center. I called to no avail. Universities all have office phones, but people only answer their personal cell phones anymore. I sent emails explaining what I wanted to do, see if I could get my students access to that compute hardware for their class projects, and got zero answer. I learned later that the compute hardware was just available for funded research projects and not for students in classes with $8,000 tuition fees per student with 100 students in the class. So university students don't have access to large compute farms and hence can only work on toy problems that run on their personal laptops. And that is not what the industry needs from our graduates. Okay, second part of this paper, how to start a new Cold War over generative AI. Cold War I is most commonly referred to as the American-Soviet Cold War of 1947 to 1989. It is clear from the political dialogues of the current and previous United States presidents and the president of China that we've moved from a slow, plodding, partial Cold War to a full-on Cold War 2.0 over the hardware and software technologies in and around generative AI. The Wikipedia definition of Cold War is the following. A Cold War is a state of conflict between nations that does not involve direct military action, but is pursued primarily through economic and political actions, propaganda, acts of espionage, or proxy wars waged by surrogates. So if we look at the global block of the export of NVIDIA hardware, the chips that are manufactured for that hardware and the hardware that designs and makes the chips for that hardware, that we have clearly entered Cold War 2.0 with China and its surrogate countries, in my opinion. The importance of surrogates in Cold Wars, by the way, is something to understand. They are basically other countries that provide political and economic support for the will of the country against whom the technology blockade has been placed. The question becomes then, how well did technological restrictions placed by the United States against the Soviet Union work in Cold War I? In 6, we see the following. The Cold War period saw a dramatic expansion of state-funded science technology research. Government and military patronage shaped Cold War techno-scientific practices, imposed methods that were project-oriented, team-based, and subject to national security restrictions. So the key thing is state-funded science and technology allowed this to happen in Cold War I. I remember this well when the security manager at the Naval Postgraduate School brought me into the SCIF, which is Secure Compartmentalized Information Facility, to hand me the ACM, Association for Computing Machinery, keyword list that the ACM used for categorizing all submitted papers to ACM journals. Security manager was concerned that I was giving a talk in Japan at a conference on virtual reality, and that security manager told me that Japan was part of the Warsaw Pact. He insisted that I could not speak in Japan on anything on that ACM keyword list. He was crazy, so I went and gave my talk anyway, and when I returned, NPS had enough sense to replace him with someone else who actually knew which countries were in the Warsaw Pact. It seemed to me at the time, 1986, that the field of computer science was pretty global, that our tech papers were published and available to anyone who wanted them. Now they're all on the internet, so the only thing that you can really be blocked during Cold War 2.0 is specialized hardware to China and its surrogates. Software and the algorithms underneath cannot be blocked during a Cold War, especially since the country that sends the most graduate students to computer science and electrical engineering programs in the United States is China. with some departments in those fields being 80 to 85% People's Republic of China nationals. The only way we can block this technology transfer is to provide permanent visas or citizenship to those students upon graduation so that they stay in the United States. We should do that, honestly, for anyone from any country who has completed a master's or a PhD or, heck, a bachelor's in this field. All right, conclusions. The title of this column is Generative AI Changes the World, maybe, and I kind of rambled on about how generative AI changes all teaching and maybe even the politics of the world. I'm going to leave the word maybe at the end of the title, as we never know completely what the future may drop on our head. Here's the references, and I'll just leave them up for a second. You can always pause this video to go find them. In acknowledgments, the author wishes to acknowledge all the AI and generative AI researchers that are connected to him on LinkedIn and Facebook. Their online presences, commentaries, and latest published papers are greatly appreciated. The author also wishes to thank all the wonderful students that have been in his classes over the years. The 4,000 plus students that took courses from me over 18.5 years at USC were all wonderful, and I follow all of them on LinkedIn and other social media platforms to see their fantastic futures. If you want to send an email to me, comment about this paper, or read other things off my website, it's there. Happy to chat. If you wish to write a rebuttal column or write a column for the games column of IEEE Computer, please let me know. I'm looking for guest authors. I write every other month, and the alternate months, we're looking for people to fill those in. Anyway, this has been the games column. I'm Mike Zaida, and what I'm going to do is stop sharing this right now and say have a great day, and I hope you enjoyed this presentation.